the study of affine schemes and more general schemes, is a central part of modern algebraic geometry. It, however, is difficult to get its overview for beginners. So in order for you to understand it, I broke it down into 10 steps. The second step is commutative algebra. So let's delve into the second topic, commutative algebra. Commutative algebra is a branch of algebra that studies commutative rings, their ideals, and modules over such rings. Both algebraic geometry and algebraic number theory build on commutative algebra. In essence, commutative algebra is the study of algebraic structures, in which the operation of multiplication is commutative, meaning that for any two elements a and b, the equation a times b equals b times a holds. The most familiar example of a commutative ring is the set of integers, where the multiplication of any two integers remains the same regardless of their order. Here are some key concepts in commutative algebra. 1. Ideals. An ideal is a special subset of a ring. It is closed under addition and subtraction, and if you multiply an element in the ideal by any element in the ring, the result is still in the ideal. Ideals generalize the concept of an integer dividing evenly into another integer. 2. Prime and maximal ideals. These are special types of ideals. A prime ideal is an ideal that has the property that if a product of two elements is in the ideal, then at least one of the elements is in the ideal. A maximal ideal is an ideal that is as large as possible, without being the entire ring. Prime and maximal ideals play a role in commutative algebra, similar to that of prime numbers in number theory. 3. Ring homomorphisms. These are functions between two rings that preserve the ring operations. They are the morphisms in the category of rings, and they allow us to talk about concepts like isomorphism and quotient in the context of rings. 4. Modules. A module over a ring is a generalization of the concept of a vector space over a field. Modules provide a context in which we can talk about linear algebra in the setting of arbitrary rings, not just fields. 5. Spectrum of a ring. Given a ring R, its spectrum, denoted spec R, is the set of all prime ideals of R. This set, equipped with a certain topology called the Zariski topology, is a fundamental object of study in algebraic geometry. Commutative algebra is a foundational subject in modern algebraic geometry, where geometric concepts are interpreted in terms of commutative rings and their ideals. It also has important applications in algebraic number theory and algebraic topology.